Hello. We will continue our discussion on computer networks and internet protocol. In last few lectures, we are discussing on data link layer, layer 2 in the OSI, also in important layer, also in TCP/IP. So, we have looked into Ethernet and different other features of layer 2, and today we will see something on flow and error control. You will find similarity or between the flow and error control what you have studied in or in transport layer or in the transport layer phenomena, where we in transport layer it takes care of the end to end process, right. That process, a process in system 1 is process P in system 1 talking to process Q in system 2, and there is a process to process communication, whereas in this case we have a hop to hop communication, right, that in layer 2 hop to hop, this system connected to a nearby switch. So, it is that hop connectivity is there. We also understood, we know that a particular Ethernet frame or we have a source address, destination MAC address and the payload which is carrying from the higher layer, right, and with other things like error checking, preamble, SFD and type of things. So, what is important when we communicate, especially these days when we have a switched network, switched full duplex networks and things, that to how these error and flow control mechanisms are handled in these scenarios, right. So, we will take a overall overview of the overall flow and error control, and as I am again repeating that the overall mechanism is conceptually is similar to that what we have seen in the transport layer, but here at the we are doing at the data link layer. So, flow control coordinates the amount of data that can be sent before receiving the acknowledgement, right. So, what is there whenever I am sending a data to somebody, right. So, after sending I am expecting an acknowledgement the data is received okay or not okay to resend. So, what flow control coordinates the amount of how much data you can send before receiving the acknowledgement type of things, every bitwise, bytewise, kilobyte wise or chunk wise and whatever the things, right. Flow control is a set of procedure that tells the sender how much data it can transmit before it must wait for an acknowledgement from the receiver, right. So, that is a mechanism. It says that you say, I say that you send every packet of so much things or every frame and get a acknowledgement, send the next frame, or I say that you send 5 frames, wait for the 5 acknowledgement and type of things. I say 5 frames in a sequence and then wait for the last the maximum acknowledgement, thing that all will be there. So, it is a mechanism, it is a procedure, it is a protocol, it is a overall procedure need to be there. Receiver has a limited speed at which it can process incoming data and a limited amount of memory in which store the incoming data. So, what we see that the receiver, it is basically the receiving end, it has a speed, at a limited speed or at a speed it can receive, it can store some of the data and type of things. Receiver must inform the sender before the limits are reached and request that transmitter to send fewer frames or stop temporarily, right. So, if it is overwhelmed with the data, it must send that sender that two things, it is hungry of the data, it is basically dearth of data. So, it asks the sender to send more, or if it is overwhelming the data, it should say that the stop sending and or at a reduced speed, right. So, this all are has to be through a procedure which is primarily a flow control mechanisms, right. Since the rate of processing is often slower than the rate of transmission, receiver has block of memory or buffer for storing the incoming data until they are processed, right. In general, the rate of processing with more high speed things are coming up. So, rate of processing the data is often slower than the rate of transmission. So, usually you are overwhelmed with the data. So, receiver has to maintain a buffer or a memory block where the data can be incoming data can be stored and processed, like we have seen the stored and forward is store the data, process the data and type of things. But there is a limit for the buffer also, that how much you can, it is not a indefinite buffer, you can go on storing indefinite time, right. So, there is a restriction on the how much buffer you can store the data and type of things. So, on the other hand, so one aspects of a Ethernet or layer 2 or data link layer is to have a mechanism for flow control, right. Otherwise, faithful communication at a or at a expected rate etc., will be difficult to maintain unless there is a flow control mechanisms which manages the. So, that is one important thing. Other aspects of the thing, the error control. The data is sent from the receiver sender to the receiver does not reach it, received it, or while sending the acknowledgement is lost or delayed. Sometimes it is not lost, it is delayed, corrupted and type of things may come up into the things. So, that is all important to how to overall control the error in this layer 2 transmission. So, error control includes both error detection and error correction, right. It allows receiver to inform the sender if the frame is lost or damaged during the transmission and coordinate the retransmission of the of those frames by sender, right. So, it allows the receiver to inform the sender that whether the frame is lost or damaged during the transmission and coordinate the retransmission of those frames by the sender. So, if there is a loss of frame or damage of the frame, that should be retransmitted. Error control in the data link layer is based on a concept of ARQ or automatic repeat request, right. Whenever there is an error is detected, specified frames are retransmitted, right. So, it is a automatic repeat request. So, it is requesting for a automatic repeat of the things. So, that is a mechanism which is there. So, error and flow control mechanisms as you might have seen earlier also. So, one is the stop and wait mechanism and they go back in ARQ mechanism and selective repeat mechanism. So, these are the three predominant mechanisms which is followed or which is deployed in the layer 2 of our standard local area network implementations. So, in case of stop and wait, it is pretty straightforward. Sender keeps a copy of the last frame until it receives the acknowledgement, right. So, senders keeps a thing for the identification both the frames and the acknowledgement are numbered alternately 0 and 1. So, 0 1 0 1 0 1 and type of things, right. So, once the frame is sent as a 0, acknowledgement comes as a 1, send the frame as 1, acknowledgement comes as a 0 and alternatively goes on, right. So, the receiver on receiving the acknowledgement it gets the thing that it is successfully transmitted. The sender has a control variable S and holds the number of the recently sent frame 0 or 1, right. So, control variable takes care of the things. The receiver has a control variable R and holds the number of the next frame expected to the 0 and 1, right. Sender starts a timer when it sends the frame. If an acknowledgement is not received within a allocated time period or within a threshold period or within the timeout period, the sender assumes that the frame was lost or damaged and resends it, right. Receiver sends only positive acknowledgement if the frame is intact. Acknowledgement number always defines the number of the next expected frame, right. So, that means you see here the acknowledgement 1 means the next expected frame is 1, acknowledgement 0 is the next expected frame is the with the S of the sequence 0 and type of thing. So, this is a very simple mechanism, but it allows for this flow and error control, right. So, frame 0 is sent, acknowledgement sent back as 1. On receiving the things, it asks for the frame 1 is sent, acknowledgement sent as a 0, and so on and so forth. So, alternately it is 0 and 0 1 0 1, things will go on. Stop and in stop and wait ARQ, lost acknowledgement frame, there is a acknowledgement frame is lost, right. So, when a receiver receives a damaged frame, it discards it and keeps the value of rate. In this case, it receives is check that it got a damaged frame, it discards it and keep the R equal to 1. After the timer at the sender expires, another copy of the 1 is sent, right. So, it once within the time limit the sender does not receive the acknowledgement, it will send another that frame 1 is retransmitted to the receiver, means sender to receiver, right. So, so this is a it is a lost frame, right. So, here it is a lost acknowledgement frame. So, it was the lost frame and this is lost acknowledgement frame. So, in this case, if the sender receives a damage acknowledgement, it discards it, right. So, the sender gets the acknowledgement which is a damaged one and it discards it. How it is identifying, because you in the format we have the FCS, right, frame check sequence is there, that CRC 32 and so on and so forth. It is able to find out that whether there is a error or not. When the timer of the sender expires, the sender retransmit the frame 1, right. Receiver already received the frame 1 and expecting to receive frame 0, therefore, it discards the second copy of frame 1, right. So, because it is already received a frame 1, found it faithfully and but received again frame 1, so it discards the second copy because it is expecting a frame 0, right. So, that way it goes on, means it handles that lost acknowledgement. So, even the acknowledgement is lost in the retransmission phase, it can basically detect it. Stop and wait delayed acknowledgement frame. So happened that acknowledgement is sent, but it is delayed, right. Acknowledgement can be delayed at a receiver or due to some problem, right. It is received after a timer for the frame 0 has expired. Sender transmitted a copy of the frame 0, however, R equal to 1 means the receiver expect to see a frame 1, right. So, receiver discards the duplicate frame 0, right. Previously what was there, that it is has a duplicate 1 because of the acknowledgement problem. Here there is a delayed acknowledgement and the sender thinks that the frame has lost, it will retransmit the frame again and it discards the frame 0, because frame 0 twice transmitted, it discards the 0. Sender receives 2 acknowledgement, it discards the second acknowledgement. If the sender receives 2 acknowledgement, because the actual delayed one and now the actual one, and then it discards the second acknowledgement. There is a concept of piggybacking, right. Now, because this both sending data and acknowledgement are eating away space. So, where we have a both communication, both side communication, like station A, B both have the data to send, then a method to combine data frame with acknowledgement, the data frame itself carry the acknowledgement. So, acknowledgement frame piggyback on the data frame. Instead of sending separately, station A sends the data frame that includes an acknowledgement, station B does the same thing, piggybacking saves bandwidth, right. So, instead otherwise this acknowledgement frame should have been another channel, right, however small it may be, it requires some bandwidth to transmit, right. So, this is piggyback on the other means on the data which are sent across A and B. Disadvantage of stop and wait: in stop and wait, any point of time there is only one frame that is sent, right, and waiting for the acknowledgement. So, it is sent, waiting for the acknowledgement, still the timeout and type of things, right. this is not a good way of utilizing the transmission media. So, that is a when the media, keeping the media underutilized or not utilized for a longer time is not acceptable. So, there are two protocol, is one is go back N, another is selective repeat ARQ, go back N ARQ and selective repeat ARQ, which are used to take care of this underutilized bandwidth or that are problem. So, in go back in ARQ, we can send up to W frames before the worrying about the acknowledgement. Send the W frames. We keep a copy of these frames until the acknowledgement receives. This procedure requires additional feature to be added in the stop and wait ARQ, right. So, a bunch of frames are sent, and though the copy are kept, instead of waiting that every acknowledgement that frames are sent, and the acknowledgement when it is coming, it is goes on reconciliation, or what we say that goes on acknowledging the frames, or if the acknowledgement not received and said that it goes retransmission is required, and so on and so forth. So, as we have a bunch of frames, there is not one sending, one receiving and type of things. So, in this case what we require is a sequence number, right. Frames from the senders are numbered sequentially. We need to set the limit, since we need to include the sequence number of each frame in the header, set a limit. So, if the header frame allows m bits for the sequence number, the sequence number range is 2 to the power 0 to 2 to the power m minus 1, right. For m equal to 3, sequence number is 1, 2, 3, 4, 5, 6, 7, right, or this is the sequence number we are having. We can expect the sequence, we can repeat the sequence number of those things, right. So, it is 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7 and so on and so forth. So, the sequence number can be repeated on the on a regular basis. So, from the sender sliding window, at the sending it to hold the outstanding frames until they are acknowledged, we use the concept of a window, right, because unless this is acknowledged, that has to be hold, right. You cannot discard those at the sender ends. Size of the window is at most 2 to the power m minus 1, where m is the number of bits in the sequence number, right. If there are 3 bits, 2 to the power 3 minus 1 and type of things. Size of the window can be variable, the how much that all depends on the data rate, processing rate and type of things. The window slides to include new unsent frames when correct acknowledgement are received, right. So, the window slides to include new unsent frames, like here this once the acknowledgement 0 1 received, it slides to send the next things. So, up to 4 received, it slides again and go on like that. At the receiving window, size of the receiving window is always 1 for this protocol, right. Receiving window always looking for a specific frame to arrive in the specific order. So, whether it is sliding or not at the sender end, receiving is waiting for that specific number of frames, maybe in the sequence, to wait for the in a specified order, right. Any frame arriving out of order is discarded and need to be retransmitted, right. Any frame arising due to say multipath, delay, etc. So, it will be out of order resend. Receiver window slides so, this is the receiver window slide shown in the figure. The receiver is waiting for frame 0 in figure 1, and then when it is received, it slides to the waiting for frame 1. Control variable, sender has 3 variable S, SF and SL. So, one is the end of markers, that is what we say first frame, last frame, and AS is the currently sent frames, right. Receiver has only one variable R to hold the sequence number of the frame it expects to receive. So, it is expecting 0 to receive, it will be on that things. If the sequence number is the same as the value of R, the frame is accepted, otherwise rejected. So, the if things are received as 0, as it is waiting for the 0, then it is accepted, otherwise things are rejected. Acknowledgement, as we see, plays a important role, right, that how the acknowledgement is there. Receiver sends positive acknowledgement frame is received in safe and in order, that means it is correct and in order. If the frames are damaged out of order, receiver silent and discard all subsequent frames until it receives the one it is expecting. So, it is instead of it is expecting 1, instead of 1 it is receiving 2, 3, etc., it discards all frames, right. Then the sender resends all the frames beginning with the one which has expired timer. For example, suppose the sender has frame 6, but the timer for the frame 3 expires, then the senders go back and sends the frame 3, 4, 5, 6. This is called go back in ARQ. The receiver does not have to acknowledge each frame received, it can send one cumulative acknowledgement for several frames, that is also possible. So, this is the go back in ARQ. Sender keeps track of the outstanding frames that are and updates the variables and windows as the acknowledged arrives, right. And in case of a lost frame, say in this case frame 2 is lost, when the receiver receives frame 3, it discards frame 3 because it is expecting 2, as we are discussing. So, it was expecting 2 here and receives a 3 instead of 2, it discard. The timer from the 2 expires and the sender side, and the sender sends frame 2 and 3 go back to in, that is go back to 2 in this case. Go back in ARQ, damage, loss, delayed acknowledgement. If the acknowledgement is damaged or lost, we can have two situations. If the next acknowledgement arrives before the expiry of any timer, there is no need for retransmission of the frames because the acknowledgement are cumulatively in this protocol. So, it is a cumulative, so that if the next acknowledgement arrives, there is no of retransmission. If AKC1, ACK1, ACK2, ACK3 are lost, ACK4 covers them if it arrives before the timer expires, then it is a cumulative thing. If ACK4 arrives after the timeout, the last frame of all the frames after that are resent, right. Receiver never resends an acknowledgement. So, receiver never resends an acknowledgement, it is only once it sends. A delayed acknowledgement also triggers the resending. So, a delayed acknowledgement is also in the case of it is like a damage or loss, and it triggers a resending of the frames. So, on the sender side, go back in ARQ, the size of the window must be less than 2 to the power m, size of the receiver is always 1. If m equal to 2, the size is 2 to the power 2 minus 1 is 3. So, figure compares the window size of 3 and 4, that how things will be there, accepts as the first frame in the next cycle and error, and so it goes on looking at the things, right. So, though there is a lot of frames are lost, it has got a erroneously, you got the things and erroneously a 0, and it is expecting this 0 and mistaken to the 0, and which is erroneously accepted. Whereas, in this case, if there is a loss, it is expecting 2, and but at the 3 it correctly discarded. So, it is not received a 0, so it is correctly discarded, right. So, it is also that window size plays a role in this sort of scenarios. Selective repeat ARQ, sender and receiver windows, this is another ARQ mechanisms. So, go back in ARQ simplifies the process of the receiver side, right. Receiver only keeps track of only one variable, right, and there is no need of buffer out of order frames, and simply discard the things. If anything out of the frame coming in case of a go back in ARQ, then you just simply discard the thing. So, that was the thing, right. However, in selective repeat ARQ only damaged frames are resent, right. more bandwidth efficient, but more complex at the processing. It is selective repeat, that means you are not discarding. In case of go back n, if you are finding one out of order, discard everything after that, but in selective repeat you are not discarding all, you are only discarding which are erroneous or damaged frames and type of things, right. You are so selectively disjectively requesting resend from the sender for the selective frames. It defines a negative acknowledgement or NAC to report the sequence number of a damaged frame before the timer expires. So, it sends a negative acknowledgement or NAC, right. So, here instead of in the case of go back n, what we have seen, there are this is SF, SL and S was there, and whereas here we have RF and RL, frames that cannot be accepted, frame received and acknowledged, right, out of that things which are received and acknowledged. Here frames acknowledged, frames awaiting acknowledgement is after that, right. So, in selective repeat ARQ, lost frame 0 and 1 are accepted when the received because they are in the range specified by the receiver window of the frame 3. So, it is within the receiver window size. So, it is 0 and 1 are accepted when received because they are in the range of the thing, right. Receiver sends a NAC 2 to show that the frame 2 has not been received, right, and sender resends only frame 2 and it is accepted as it is the range of the window, right. So, this range of the window matters much. So, if it is within the range of the window, so and then there is you receive a NAC of request repeat or selective repeat of a particular frame, then it is resent by the sender. So, again selective repeat ARQ, the sender window again plays a important role. Size of the sender and receiver window must be at most half the 2 to the power m, that means m equal to 2. So, size will be 2 to the power 2 by 2. So, window size is 3 and all acknowledgement are lost. Sender sends duplicate frame 0, right. So, like in other case also, if it is window size is greater than 2 to the power m minus 1, that means 2 to the power m divided by 2, then I can accept this one, though it was damaged, I accept this erroneously accepted, whereas if it is within that thing, it is correctly discarded by the receiver. So, window size 3, all acknowledgement is lost, sender sends duplicate frame 0, windows of the receiver expect receive frame part of the window, so accept the 0 and the first frame of the next cycle. So, it is a error. So, it is accepted in a erroneous manner, right. So, what we see here in this sort of flow and error control mechanisms. So, the sender receiver with help of acknowledgement, in case of the first one stop and wait, it is everything is acknowledged, every frame to be individually acknowledged, but in go back in, what we have seen that the receiver has only one pointer, whereas a bunch of frames can be sent from the receiver from the sender end, and it also send a cumulative acknowledgement, has the option of sending cumulative acknowledgement in repeat ARQ, selective repeat ARQ. So, in case of go back end, if there is a error, everything after that need to be retransmitted, whereas the mechanisms is the next mechanism has a better utilization of the bandwidth. When it is a repeat ARQ, then it sends only those selective frames which has damaged or erroneous things like that, right. And in both the cases, last two cases what we have seen, this window size plays an important role, right. otherwise you may erroneously accept something, right, if the window size is not properly maintained. So, that is important for things. This flow and error control mechanism over and above tries to provide a better utilization or better flow mechanisms within the thing. So, you have a better utilization of the bandwidth or provide a better quality of service for these mechanisms, right. So, this is the overall flow and error control mechanisms. So, with this we look at we conclude our basic flow and error control mechanism in the data to data link layer, and also we see that this provides this helps us in providing a better utilization of the bandwidth, right. That is, two issues are there. One is that bandwidth is not available, like you have a 10 Mbps and a more data to the, you have a higher bandwidth, but due to improper utilization you may not be exploiting that in a proper way. So, in subsequent lecture we will see other aspects of the things. There are several data link layer or switching aspects, those things we will be looking at, which are which are some of the things are in also have linkage with higher level network layer phenomena. So, that will in the subsequent lecture or on this particular series of lectures we will be looking at. So, let us conclude today. Thank you.